I'm Paul Williamson with the Lexus College. We're responsible for training Lexus dealers everything they need to know to service your Lexus. Today we're going to talk about electronic throttle controls. Cars used to have carburetors, where a mechanical pedal below your foot controlled the carburetor on the engine, but modern vehicles use an electronic throttle control system. The accelerator pedal now gives an electrical signal of how far you've depressed it to an engine management computer. The computer then controls an electronic throttle on the engine to determine how much air enters the engine and therefore how much power the engine produces. This desktop simulator is used to train technicians how to diagnose fuel injection systems. It has the components we've talked about, the accelerator pedal, the throttle, and this is the engine control module, the computer. All of these are active so that when the vehicle is turned on, moving the accelerator pedal causes the throttle valve to move in proportion to the accelerator pedal motion. The fuel injection system has a number of sensors detecting everything from temperature to pressure, revolutions per minute, and, of course, accelerator pedal position. And all of these sensors can be diagnosed. Anytime one of them fails, the engine control module records that failure and the code can be retrieved later for diagnosis. Let me give you an example. Under normal conditions, we've seen how the throttle moves in proportion to the accelerator pedal. But if I create a fault in one of the two sensors on the accelerator pedal, notice how the throttle closes. That's all you've got is an idle. The fail-safe mode is that the vehicle will idle to the side of the road until you can have it repaired and return to normal condition. In order for the fuel injection system to know how far the accelerator pedal has been depressed, there are actually two sensors on the top of the pedal, and they both have to work together. If either one fails, that's detected as a malfunction, and the engine has a fail-safe mode, it'll return to idle. Similarly, there are two position sensors on the electric throttle assembly. When the motor drives the throttle open, both sensors have to confirm it's moved to the correct position or it'll be shut off. The electronic throttle system is even capable of diagnosing non-electrical failures. Let's take the case of an object becoming stuck in the throttle. When this happens, the engine is completely shut off until you fix the mechanical problem and restart the vehicle. The system can even detect interference that comes from outside of the vehicle. If the throttle motor sees a voltage that did not come from the engine control module, the entire engine is shut off. Nearly all automakers have adopted some form of electronic throttle control to improve fuel economy, to reduce emissions, and to enable other important safety features such as stability control and traction control systems. As you've seen, thorough self-diagnostics are built into the engine management system. If a fault is detected in either of the two pedal position sensors or either of the two throttle position sensors, the vehicle goes into a fail-safe mode, which is to idle. The driver would also be alerted by the check engine light in the dash. If there's a discrepancy between the position of the accelerator pedal and the electronic throttle assembly, the fail-safe is for the engine to shut off. If there's a mechanical problem or obstruction, or if the throttle motor sees a signal that did not come from the engine control module, the fail-safe is for the engine to shut off. Unintended acceleration involving Lexus vehicles has been methodically investigated on several occasions over the past few years. None of these studies to date has ever found an electronic engine control system malfunction to be the cause of unintended acceleration. Our electronic throttle control system incorporates overlapping fail-safe features linked to several sensors. The occurrence of any problem causes the system to return the engine to idling mode or to shut it off. We have conducted rigorous testing under extremes of electromagnetic interference, vibration, and other adverse conditions to conclusively verify that the system cannot accidentally induce acceleration.